Hello student, it's Dr. O. Today I'm going to go over hypothesis tests about population proportion pi. So let's get it started. First of all, we need to looking at the argument or claims. What kind of claims is that? So 5.8% of job applicants, and the claim that does the result to suggest that fewer job applicants now use drugs. So corresponding percentage or proportion is 5.8% and less than that. So we build a alternative hypothesis correspondingly pi is less than 0.058. And naturally we can get null hypothesis pi is equal to 0.058. Under the testing of hypothesis about proportion, we don't need to worry about probability distribution anymore because we always testing with the standard normal distribution. So our test statistic is G all the time, and the formula correspondingly we can see. So P sample proportion minus pi 0, the value proportion from the null hypothesis value, and total square root pi 0 1 minus pi 0 over then n. So in this case, we can observe that 558 values and random sample of 1520. So P itself is 58 divided by 1520. Pi 0, we know 0.058 divided by square root of pi 0, 0.058, and 0.942. This is 1 minus 0.058, and then n is 1520. So you plug in value in the calculator, you should have negative 3.31. So you will get this value. Originally negative 3.309, or round up to the third digit of it, you will get the 3.31. So this one is a statistic from the standard normal, and we're gonna looking at this value or corresponding significance level. We will refer to the value and decide we can reject or accept or not. But today I'm going to looking at the cases we are considering. So some questions we always give so many different numbers of or varieties of alpha or significance level. So can you test with all different alphas at the same time or more efficient way? So for example, so somebody claimed that how about alpha is equal to 0.5% or 1% level or 2.5% level and 5% level and 10% level and maybe 15% level. So all different alpha level, how we can test it the more efficient way. So basically we have a three method to testing hypothesis, as I told you, right? So first of all, using a confidence interval, construct a confidence interval, and then testing a hypothesis is one way. And second one, and generally we're using test statistic is another way. And number three, that's usually right now we are using this method and the p-value method. So each one of the method is good or strong point or weak point of it. So basically test statistic itself, using a test statistic, very general and conventional method, and you can use it in general setup. but all other two methods have a strong point of under the situation. Confidence interval cases, right? We have variety of null hypotheses, like how about pi is equal to 0.05, pi is equal to 0.08 or 0.09, and all the each values you claim that, or some other people claim that the situation like this hold different number of pi zeros. So which is the value of null hypothesis can be changes and keep asking about the testing hypothesis. Then once you build the confidence interval and this each one of the values inside of interval, you cannot reject it. If it is outside of the interval, you can reject the null hypothesis. So one confidence interval cases we explained in the classes like that, right? And today what you're going to do is, we need to use p-value under the case that, whole different ops. So in this case, once you setting up or calculating the p-value and then compare with each one of these values, p-value is less than or alpha level, you can reject the null. So let's get into it with our test statistic 3.31, and this one is less than that value, so we can do that. This is one tail test and less than, so left hand side, right? So we're going to looking at the negative value, and the tail side of 3.31 is necessary to calculate, and we're going for the G table. And there is a bunch of G table you can looking at it, but this one is showing this value, which is, so from the negative infinity to this G value, so this area is given like that. So this 1 minus total of this value is what we are looking for as tail side of this value, right? So to get that, 1 minus each one of these values is necessary. So again, when you're looking at it, right, 3.31, if it is, this standard normal table is symmetric, so it's the same as negative 3.31, and the left hand side of it is same as 3.31 and the right hand side of it, right? So 3.3, this one is 0 and this one is 1, but the value itself is the same as 0.9995. So total area is 0.9995, so this area is 0.0005. So p-value, is directly 0.0005. So in this case, from that p-value is equal to 0.0005. So what is that? Another way, 0.05%. So this value is very small and very significant. As p-value is smaller, then you say it is a more significant case. So can we reject? Yes, right? 15% is way bigger than 0.05. You're going down all the way, even though 0.5%, 0.05 is less than 0.5. So all these cases, alpha level, we can reject at all. So, and also, we can say that we have a strong evidence and a strong supporting, enough evidence to say pi is less than 0.058. In other words, we have a strong evidence that fewer job applicants now use drugs. Thanks for watching. See you next time.